Yo, what's up, guys? Welcome back to another video. And today we're gonna be talking about something that's very fundamental to nearly the base of like all mathematics, vectors. You usually start out by learning this usually in pre-calc or in calculus 1. It's very fundamental towards everything, such as your physics classes, your other physics classes, and your calculus classes, calc 3, all those things. But today we're gonna be talking about vectors, but in 2D, which just means we're just going to be looking at the x and y axis. And so you might be wondering to yourself, what is a vector? Why does it matter? Like, what am I going to do with this information? First off, we have to establish a significant difference between a vector and a point. A point is just something annotated with parentheses of x and y. So this would be a point. However, a vector would be like an arrow. It would have like brackets like that, like a little like alligator mouth, x, y brackets. And then from here, we could write the arrow such as that. So you might be wondering to yourself, what does a vector have that's so important? A vector has both direction and magnitude. Magnitude meaning the length of the vector and direction meaning where the vector is. The point, I believe, only has direction, which I think is the main difference. I'm not a math major. Don't quote me on that. However, a vector is just that. It has direction and magnitude, and it's very, very important when you're talking about physics, such as, work-force product, when you're talking about something else, or when you're talking about normal vectors and stuff, but we'll get into that like so much more later. So in order to work with vectors, you have to realize that let's take vector A. The annotation for vectors is usually A or B, whatever you want to call the vector, with a little arrow on top indicating that's a vector. Let's say you had vector 4, 7. What does that mean? So essentially what that means is you would draw your axis. This is y, this is x. Essentially what you would do is you would go 4 to the right, because that's what it's saying on the vector. So let's just say this is right. So you go 4 to the right, which is 1, 2, 3, 4. So here's your x component, which is 4, and then you would go 1, 2, 3, 4, 5, 6, 7 around here, which is your y component. And from there, you would mark out the spot where it is. It's around here, and then that is your vector, which is pointing in the direction in the first quadrant. Essentially, what you just did was graph out a point, but instead it just has magnitude. What does magnitude even mean? If you recall, it took us about x4 components to the right, and then you can also draw this. This is called tip to tail, or is it? Yeah, no, wait, what? Yeah, tip to tail. It just basically means that when we add all the components to get a vector, we can essentially break down the original vector that we did into much smaller components. So we can break it down into 4, 0, and then 0, 7. Ultimately, there's a rule that every vector can be broken down into infinitely many pieces. That's too complicated. So essentially, what we can do is we can add these vectors together, and we get vector A, which is 4, 7. So from here, we do tip to tail, from the tip of the front of the first vector, and then we attach the tail of the second vector, and here we get our full vector right here. Magnitude just means how long it is, and you might be wondering to yourself, how do we get how long it is? Well, 90-degree angle. Pythagoras theorem time. Yeah, so essentially you just do Pythagoras theorem for this. So you do 16 plus 49. I'm not a mathematician, just 5, 6, wait, am I adding? What? Wait. I think that's 65. I think that's 65. So the magnitude will be root 65. I think. I don't know. I can't do math anymore. But let's say you had two vectors together. Let's say you had vector A, which was equal to 0, 2. And then vector B, which was equal to 6, 7. How would we add these two vectors together, both algebraically and visually? So what you would do is you would draw your x and y axis. And from here you would graph out A, which in this is just 0, 2. So we go 0 to the x, then we go 2 to here. So this is your vector. And then 6, 7, let's just say this is 6 and this is 7. Your vector would be here. Essentially, the way you add them is, for me, I like to add them algebraically first, because I'm not a visual person. So what I like to do is just like to add them. And when you do, what you do is you add the x components and the y components. You never mix them in. You never mix them in, because then it just messes up the whole operation. So you only do, let's say this is x1 and y1, and then x2 and y2. You would add x2 plus x1 together, and then y2 plus y1. So you would get 6 and then 9 as your new vector. Let's call it vector C. So 6, 9 would be here, but then it'll be a little bit taller around here. And this makes sense because, again, tip to tail method. You would do 6, 7 first, and then you would add the vector of 0, 2 over here. And then from there, you would draw the new vector, and that's how you get the new vector. So let's say we have the same example. We have vector A, which is 0, 2, and then vector B, which is 6, 7. How would you be able to find the difference between these two vectors? Let's say we had vector B minus vector A. Algebraically speaking, it's the same thing as just adding them, but you're just subtracting both of the components. So you would do 6 minus 0, and then 7 minus 2. And then your new vector will be 6 and then 5. And we can do the same thing. Instead, we just flip A. And this is confusing. So basically, you've been lied to your whole life. I'm sorry to tell you, you have been lied to your whole life. The reason why I say that is because subtraction, as my physics professor says, has been a fucking lie to you. It's always been a lie. It's always been a lie. You don't actually subtract things, you just add a negative value into it. And so if you want to subtract these two vectors, you're really doing vector B plus negative vector A. And this is important. Whenever you have a negative vector, essentially you're multiplying it by a scalar of -1. And then that just flips the numbers around. So if vector A were to be multiplied by -1, then your new vector will be negative A vector, which is 0, -2. This essentially flips the whole operation upside down. And again, you just add them by using tip to tail method. And you would see that our new vector is lower, but in the same x component as before. 6, 5. Isn't that just insane? So that's how you add and subtract vectors. And now we're going to talk about scalars. Scalars is just a fancy word to say how much we multiply things. So essentially, let's say we had the A vector, which is equal to 5, 10. Let's just say that's 10 and that's 5. And now let's say that we wanted to multiply the vector by 2a, or by 2. Essentially, what you would do is you would just multiply 2 times the vector. And then this new vector would be 10, 20. So essentially, you would have to draw your x-axis for longer. But it would just be twice its size. Similarly, what you could do is we see that a vector is equal to 5 over 10. But you can actually transfer out a 5 or factor out a 5 from the vector. So you could really say that the original vector, let's just say that's the original vector. Let's just say you could say that the original vector 1, 2 is actually the original vector because it just has a scalar of 5. Similarly, with negative numbers, again, when you have a negative vector, you're essentially just flipping the whole operation on both of its components. And this is what I mean. Say we had b vector, which is equal to negative 1 and 2. When you do negative b vector, or multiplying it by negative 1, you would get 1 but negative 2. So essentially, a scalar is just multiplying that whole component, x and y, by whatever you want to multiply it by. Example again, we have b vector. And it kind of looks like this. We're going to use the second quadrant now. We're going to go negative 1, and we're going to go 2 above. So right around there. If you do negative 2b, you're essentially just multiplying negative 2 as a scalar to negative 1 and 2. And then from here, you just get 2 and negative 4. That means we're going to go into the fourth quadrant now. So we're going to go 2 here, then 1, 2, 3, 4 to the negative y-axis, which is around here, and this will be our new vector. That's all a scalar does. It just makes it bigger, it makes it flip the other way, it makes it, I don't know, it just makes it do like a lot of things. There's another important vector that you must learn as well. There is something called a unit vector. A unit vector is just a vector length 1. What do I mean by that? Well, the general formula for it would be, let A be a vector. The general formula for a unit vector would be the vector A, the original vector, over the length of vector A, which is equal to your unit vector. Essentially, it's like a unit. It's a unit of just length 1. It just has length 1. That's it. Here's what I mean. Let's say we had vector A, which is equal to 10. Let's say we had vector A, which was equal to 6 and 8. 6 being my x component and 8 being my y component. From here, what I can do is to find the unit vector, all I would have to do is find length A. Length A, as we established, is just using the Pythagorean theorem. So we do 6 squared plus 8 squared, square root all that, which is 36 plus 64, which is equal to root 100, equal to 10. From here, we divide this vector, or we actually use this scalar to multiply it by 1 over 10 times the original vector. From here, we see that the original vector has now turned into 6 over 10 and 8 over 10. And we can simplify these even more. The reason why it's called a unit vector is because this unit vector, is now length length 1. And I can prove it to you. 3 over 5 squared plus 4 over 5 squared, square root that. 3 over 5 squared is 9 over 25. Plus 4 over 5 squared, which is 16 over 25. And you get the square root of 25 over 25, which is simply equal to 1. And that is a unit vector. And I'm going to end it off here because dot product, cross product, that's like a little bit more complicated. So I'm going to talk about that in the next video, and also I'm going to form views. But let's not talk about that. It's been a minute. I've been far away for a long time. So, I've just been relaxing, doing this fun engineering homework. I love engineering. As if me and my group haven't just barely finished the deadline. But anyway, that's been an intro to vectors. Hopefully you enjoyed. This is very important if you want to get into physics, engineering, any kind of stuff like that. Very, very important. Thank you for watching. Please like, share, subscribe, and goodbye.